2, Law of Cosines. Much like Law of Sines when we went through it, get this in a little better focus here. Much like Law of Sines, I'm working under the assumption that everybody's worked with Law of Cosines before, and this is primarily review. I might have a couple things to add. We're going to get right into it with our Law of Sines, and what I notice is it always starts out Pythagorean looking, and C isn't necessarily the hypotenuse. In fact, we're dealing with oblique triangles here, triangles that are not right angles. So these are just 3 sides. And it always starts out looking Pythagorean. A side squared equals the sum of the other sides squared. That it's minus 2 times, repeat these, B times C, times cosine of the angle that is opposite the side that we've isolated. So that's convertible. You don't have to memorize all 3. I've never bothered to memorize these. I'll show you what we do when we get to this alternative form. In fact, if there really was truly an alternative form, it probably should just say A equals cosine inverse of all of that. But if we have even a basic understanding of algebra, we should be able to jump from here to here in just a step. So you will see that. Then we've got a new side area formula that might be completely new to you, and here's different area formulas. We'll come back to those, but for right now we're just going Law of Cosine problems, solve the triangle. What I won't accept from you in your work is if you squeeze angles in here. I want a whole block where our solutions go. I was talking with our class the other day, and somebody kind of groaned a little bit about it, that we had to do this. A equals B equals C equals little a equals little b equals little c equals. And I said, well, time me. And I even talked through it as I did it, and it took like between 5 and 6 seconds. So we're going to place answers in a nice, neat form. Otherwise, it just becomes a big mess with arrows and just things crowded in. So here's the deal on this. Law of cosines, the benefit of law of cosines over law of sines, because it's definitely messy, is 1, it's going to solve triangles for side, and side angle side, which law of sines can't do on its own. But more importantly, because cosine is positive, negative, positive, negative, positive, negative, negative, positive, it will find an obtuse angle for us when we use cosine inverse. It'll tell us that we have 115-degree angle in a triangle. Whereas if we use law of sines, if I had an angle such as this one, an obtuse angle, law of sines is going to read that as being in the first quadrant because sines goes positive, positive. Law of sines doesn't, or sine inverse doesn't return values in the second quadrant. So, big important rule for you. If you are using law of sines to find an angle, and you have a choice, do it on a small angle, an acute angle. See, even without the diagram, with just these side lengths, I would know if there's an obtuse angle, it's B. Law of sines will be fine for finding C and finding A, but it won't find B for us here. It will lie about B and tell us it's acute. And when the triangle's drawn, no real problem. We just say, okay, well, it's just the supplement of the angle that the calculator gives us. But what if we don't know? What if we don't see the triangle and we aren't certain it's obtuse? So here's the deal. On a side problem, you're going to start with law of cosines. You could use it for any angle and not worry about that result. But then you're probably going to shift to law of sines, and law of sines will not tell you whether this is acute or obtuse. It will just always say it's acute. So I'm going to set this one up. Let's go ahead. We've got side C is 12, the side opposite B is 18, the side opposite A is 8. I can't use law of sines. Law of cosines, I can find any angle. I'm going to choose to find angle B because law of cosines will reveal an obtuse angle. So the formula is B squared equals A squared plus C squared. It starts out looking Pythagorean. The angle I want's angle B, so side B gets isolated. Minus 2 times, repeat these, AC cosine of angle B. Believe it or not, one of the most frequently ways this is missed is people put sine here. On law of cosines, people put sine. Kind of interesting. All right, so I'm going to put values in. In fact, normally I would just start by putting values in, but I wanted to show that. So b, this is 18 squared equals 8 squared plus c is 12. 12 squared minus 2 times 8 times 12, I repeat those, times cosine of b. And now, you guys are pre-calculus students. Many of you watching this probably honors pre-calculus students. So we can do this in one step. I want to get b alone. It started out, and I'm going to leave some space here, you'll see why. It started out, I've got to get all of these things away, but it started out on the other side as 18 squared. I need to subtract away 8 squared. I need to subtract away 12 squared. And all of the rest of this is multiplied by. So is multiplied, and I need to divide it away. So I'm going to divide by negative 2 times 8 times 12. And that gets cosine b alone, but I want to get rid of cosine. Cosine inverse. Excuse me. And now we're going to jump to our calculator here, make certain we're in degrees. I am. And we're going to enter this carefully and double check it. Cosine inverse, 18 squared minus 8 squared minus 12 squared. And I've set myself up for failure here because all of this has to be wrapped in a separate set of parentheses because it's in the numerator. I needed another set there, so we're taking cosine inverse of all of that. So I'm going to go second insert a parenthesis. And you can set your calculator up so it enters this as a fraction. We'd actually put it on top of the other, but not all of our calculators do that, so I'm going to go through this method. Divided by all of negative 2 times 8 times 12. I didn't hit 8. Negative 2 times 8 times 12. And then we're going to double check things. Let's see. Cosine inverse 18 squared minus 8 squared minus 12 squared divided by negative 2 times 8 times 12. We're in degrees. Enter. And angle B, I'm going to call it 127.2 degrees. A good habit, and I'll always explain what I want for my assignment, but a good habit for all of you out there is if they give you problems in values in integers, go one more place, tenths. If they give you in tenths, maybe go one more place to hundredths. All right, now we can switch to law of sines and not worry about it, but sines would not have identified this as a 127.2. So now we can go to law of sines. You could go to law of cosines if you wanted. It's just a little bit clumsier. It's just a little bit more going on there. So I'm going to find angle A. So that's going to be the sine of angle A on 8 equals the sine of angle B. Now, that angle B answer is a little bit of an error. It's rounded. So I'm going to go the sine of ANS. We'll come back and talk about that if you haven't used that before. All on 18. So angle A equals, I would multiply 8 across. It would join sine of this ANS thing divided by 18, but then I'd have to get rid of sine inverse of all of that. Okay, let's get that entered and let's talk about that ANS. Because again, angle B isn't really 127.2. It's really what's loaded in my calculator there. So, second sine inverse, and it's 8 times sine of answer is second negative is answer. And what that does, I'm sure most of you know this, it uses that value that was previously calculated. So there's sine of answer. We need to divide by 18, and we double check these things. It's easy to make a mistake there. That looks good. And angle A is 20.7 approximately. And now we could use law of sines to find angle C, but better, of course, would just be, if we trust your work, 180 minus 20.7 minus 127.2. And we get 32.1 degrees. And just like in our problems from law of sines homework, there's two quick tests that I think would eliminate or would identify 80% of errors that are made. First off, my biggest angle is opposite my biggest side, and my smallest angle is opposite my smallest side. And my two small sides, 8 and 12, add up to be more than my big side. And that's what we're looking for. Okay, number 12. Here we have a side angle side problem. Let's go ahead and time me. And that's really without rushing. It doesn't take long. We're going to go ahead and write them out this way. So angle B, by now we should identify that as 50.5 degrees. That's 50 degrees, 30 minutes. 30 minutes is half of an hour, so it's half of a degree. Side opposite A is 10.4. Side opposite C is 12.5. And just by that I can see I don't have proportions. I can't go this on this equals this on this, two unknowns. Or this on this equals this on this, two unknowns. Or A on C, two unknowns. So this is a side angle side. This is a law of cosines problem. And we don't have any choice but to find side B here. We've got the angle. So this is B squared equals A squared 10.4 squared plus C squared 12.5 squared plus, minus 2 times 10.4 times 12.5 times the cosine of 50.5 degrees. Wow, didn't give myself much room there, 50.5 degrees. So B equals, or I'm just going to do it this way, the square root of that. And if you're observant of that, well, why isn't it plus or minus? It should be algebraically, but geometrically, B is going to be a positive value. So we're going to carefully enter that, and we're going to double check it. Big square root of, I need 10.4 squared plus 12.5 squared minus 2 times, repeat them, 10.4 times 12.5 times the cosine of 50.5, and we're in degrees. And we just cursor back, check those values real quickly versus what we had. Minus 2 times 10.4 times 12.5. Really easy to make a mistake. In fact, in my first class when I was teaching this today, I made a mistake on this. So enter, or like that. Sorry, I didn't have that showing the whole time because I zoomed in. But there we have it. 9.95 rounded to tenths. I'm going to call that 10. Or 10.0. And now we can jump to law of sines, but there's a danger here. Assuming this is drawn to scale, we don't have an obtuse angle. But what if it's not drawn to scale? Could angle A or C be obtuse? Well, only C could be. It's opposite the big side. Therefore, if we're going to go to law of sines, don't allow sines to try to identify what could, the biggest angle or what could be an obtuse angle. We're going to go for this one. So it's sine of A on 10.4 equals sine of B 50.5 degrees on B, but B is rounded, so A and S. Therefore, we get A equals, I had to take 10.4 and multiply it, 10.4 times sine of 50.5 degrees divided by A and S. And then, once 10.4 was out of there, we have to get rid of sine. Sine inverse. So, clear this out. Zoom back out a little bit so we can see everything. And we get sine inverse 10.4 times sine of 50.5, close those parentheses before we divide by, answer, second, negative. And we get 53.7. So we got 53.7 degrees here. And for angle C now, don't use law of sines, 180 minus 53.7 minus 50.5, 75.8. Okay, let's move on. Number 18, I'm going to go ahead and draw a triangle up here. Leave some space in case we need some room. I don't try to draw these to scale. You're welcome to if you'd like. Angle A, I've got angle A is 48 degrees. I've got side B is 3. And I've got side C is 14. This one's 48 degrees. I can't law of sines this. I don't have a side opposite an angle or an angle opposite the known sides. So A equals B equals C equals, this is side angle side. So there's only one solution. Only on angle side side problems might we have two. If there is a solution, there's one solution. I probably should clarify. And we've got angle A is 48 degrees, side B is 3, side C is 14. What are we going to find? Side A. So A squared equals, or A equals great big old square root of B squared 3 squared plus C squared 14 squared minus 2 times, repeat them, 314 times cosine of A, but A is 48 degrees. I have enough space there? Sure I do. So, second square root of 3 squared plus 14 squared minus 2 times 3 times 14 cosine 48. Take a quick look at that. Looks good. Side A, 12.2. Might as well do our first check right now. 3 plus 12 is definitely bigger than 14. That's one of our checks. Now, angle B, angle C. Might one of those two be obtuse? Well, if there is an obtuse angle, it certainly it certainly would have to be C. C's opposite the biggest side. So I'm not going to risk going to law of sines and finding angle C that might be obtuse. So angle B, that's sine of B on 3 equals sine of A, this is a rounded value here, on answer. Or B equals, we'll get good at this, have to multiply 3 times the sine of 48 degrees, divide that by A and S, and then we have to take sine inverse of all of it. Second sine inverse, 3 sine 48. Close those parentheses because it's only the sine of 48. Divide by answer, second negative. And we get 10.5. And now for angle C, the easy way, 180 minus 48 degree angle that we have minus the 10.5 degree angle that we have, 121.5 degrees. Okay, and just one answer. If we'd have gone to this first with law of sines, it would have told us that it was like 58.5. It would have told us that it was the supplement of that, and it is not. This is side angle side. There's only one answer, and this one happens to have an obtuse angle in it. Okay. A, B, C. I've got all these sides 1.42. I've got side B as a 0.75, and I've got C as a 1.25. And this is side, side, side. I can't use law of sines here. A equals B equals C equals little a, little b, little c. A is 1.42, B is 0.75, C is 1.25. We're going to round to hundredths here since they started in hundredths. You might even go to thousands, but I'm going to go hundredths. Oftentimes that angles aren't rounded as far as the side lengths are, but we're going to go to hundredths. So we don't have, I can't do law of sines. I can see it here. It's always two unknowns in any of these proportions that I would use. So I have to use law of cosines. And technically I could use law of cosines to find any angle I wanted, and then to find the next angle I'm going to shift to law of sines. But don't forget, law of sines might lie to us about an obtuse angle. Law of cosines won't. And the only possible obtuse angle is A. It's opposite the big side, so I'm going to use law of cosines to find A. To find angle A. So that's A squared 1.42 squared equals B squared 0.75 squared plus C squared 1.25 squared minus 2 times, repeat them, 0.75 times 1.25 times the cosine of A. Good time to pause the video here and try this. Solve that for A. And hopefully you paused it, you tried it. Let's see how you did. A equals, well, it started out as 1.42 squared. I had to subtract 0.75 squared. I had to subtract 1.25 squared. And then all of the rest of this, negative 2 times 0.75 times 1.25, is attached to cosine with multiplication, so I have to divide by all of that. Negative 2 times 0.75 times 1.25. And then I'm down to just cosine A to get A alone, cosine inverse. A lot of things going on there. If you want to break that down into more steps, you may. Some people figure out what this value is, just a plain old number, and then figure out what that value is, just a plain old number, and then transfer things one at a time. But if you can follow this, it's pretty efficient. So here we go. Second cosine, cosine inverse, 1.42 squared minus 0.75 squared minus 1.25 squared. And take a look what I did to myself again. Boxed myself in because all of that, if I entered it like this in the calculator, I didn't do this on purpose this time, but I'm glad I did. If I entered it like this in the calculator would try to find cosine inverse of that and then divide the result by this. But we want cosine inverse of all of this. And you probably recognize that since I did it before. So I'm going to come back here, insert a parenthesis here. So there's my numerator, divided by, the denominator is all of negative 2 times 0.75 times 1.25. And we have that. Why do we get the big parenthesis there? That's interesting. Oh, it just has a couple sets of big parentheses. I think that's because of the squaring. That's why. Okay, and enter, and we get 86.7. Now we're going to go 86.68. So A is 86.68. I just went an extra decimal because they were working in 2 decimals here. And now we can find either B or C, but I'm such a creature of habit that if I'm going to use sine, I'm going to go for the smallest angle. I'm going to find angle B. So sine of B on 0.75 equals sine of A, and this is A, but not really, that's rounded, sine of my answer that's loaded in my calculator right here, divided by 1.42, solve for B. B equals, we have to multiply 0.75 over to sine of answer before we divide 1.42, and then we have to get rid of sine. Sine inverse. Only need one set of parentheses here, 0.75, sine of our answer. Close that parenthesis before we divide by 1.42. Looks good. And we get 31.82 for B. And now I can go 180 minus 86.68 minus 31.82, and I get 61.5. Yeah, 0.5 or 50 if you like. And let's do our quick test here. Biggest angle 86, opposite, biggest side, yep, little angle, opposite, little side. 0.75 and 1.25 add up to be more than 1.42. So doesn't guarantee it's right, but pretty comfortable that we have a good start there. Okay, I'm going to go through these two problems, leave a couple more that we're going to look at in a part 2 video. First one, not so bad, and I'll tell you what gets people on this. Let's read the directions. In exercise 25 to 30, complete the table by solving the parallelogram in the figure. And people just jump down, and then we see C here, and we're like, oh, this is C. This must be C if it's a parallelogram. That's one of the property of parallelograms. They bisect, the diagonals bisect each other, but it's not. It says the length of the diagonals, this whole length is C. This whole length is D. And that gets people on this. It'll get somebody in here, and I'll answer the question tomorrow, and I'll try to be polite about it, but that's going to get people. Okay, so they're giving us the length A, they're giving us the length B, and they're telling us that this angle up here is 120. But A and B are in that triangle, because this side would be B as well. This side would be A as well if it's a parallelogram. I'm just going to reproduce this triangle right here that has the parts that they're talking about. I didn't reproduce it very well. It's more like straight up here, up kind of at an angle like that. Looks something like this. So A is 25, B is 35, this angle is 120 degrees, and this side is C. Well, I can certainly find C. What else can we find? If this angle's 120 and these are parallel, doesn't that make theta 60 degrees? Same side interiors or consecutive interior angles on parallel lines. So we've got that one. Let's go for side C, side angle side. So this is law of cosines here, side angle side. I don't know the side opposite the 120, and I've got to have a side and an angle opposite to use law of sines. So C squared equals, good news, I know angle C. If I call this C, I know angle C. C squared equals 25 squared plus 35 squared minus 2 times 25 times 35 times the cosine of 120 degrees. Which is a weird way to give the formula, but I get it. Give it that Pythagorean feel, when actually it could just be C equals big square root of. So let's find that. Second, big square root, 25 squared plus 35 squared minus 2 times 25 times 35 times cosine of 120. And we get 52.2. So we got 52.2 units for it. And now we can find D. D's in a triangle with A and B. Let's redraw that triangle separated out from the rest of the stuff. Looks something like this. This is B, this is 35 down here. A is 25. We're looking for side D. And this angle we've determined is 60 degrees. Certainly not drawn to scale here because they're going to change values as we go. All right, let's take a look. So before we go to calculator, I guess, this is side angle side. We're looking for D, so D squared equals, or D equals big square root, 25 times 35, 25 squared plus 35 squared minus 2 times 25 times 35 times cosine of 60 degrees. So I could probably go up and grab this other one and just do a quick conversion on it. I could go second enter. What really needs to change is just that 120, I believe. Just needs to be a 60. Does that look right? And we get 31.2 2. And there we have it. Okay, a little bit more going on this guy. They don't give us maybe the most favorable values. They give us B, that's nice, 25. They give us all of C, that diagonal. They give us all of C, this diagonal. Diagonals of parallelogram bisect each other. I've got B, I've got C, but I've only got those two parts of the triangle. I don't know any angle measures. And I don't know A yet. I think I need to work perhaps with this triangle right here, one of the little 4 triangles interior. I'm going to work with that one. I'm working toward, let's say that's angle fish right there for right now. This would be fish. Okay, here's what I know. B is 25, it's here. D, half of D is 17.5. C, half of C is 25. And that's kind of favorable for us. We actually have an isosceles triangle in this case, but I'm not going to deal with it that way because what if it wasn't? So we're going to go ahead and, I'm going to go ahead and go for some angles here. I'm going to go for angle fish, and I'm going to go for angle, I'm not going to get creative here. I'm going to call it X. Okay, so I'm on a law of cosines. If there is an obtuse angle, it would be this one. This one's certainly acute. I'm going to go for this angle right here. I'm going to go for this angle and then find that one from it. So this angle right here, that would be this angle squared, excuse me, its side squared, 25 squared equals, let's see, 25 squared plus 17.5 squared minus 2 times 25 times 17 times cosine of, which one did I do here? The 25, cosine of X. So solve that for X. X is, it was the 25 squared. I subtract 25 squared, of course that's 0. I subtract, 17.5 squared. And then all of this needs to be divided. I divide by negative 2 times 25 times 17. And ultimately I need to take the cosine inverse of all of that. And I remember to do it this time with the parentheses. So on cosine inverse, parentheses here, 25 squared minus 25 squared, of course didn't have to enter those, minus 17.5 squared. All of that divided by all of, didn't divide, divided by all of negative 2 times 25 times 17, and we get 68.9. So this angle X is 68.9. So I'm going to draw this really big here and see what we've got so far. Just trying to recreate, I don't know, mine's a little askew of theirs. Trying to put in things we know down here. So things we know, they gave us that side B is 25. We knew that C is 50, so this is 25, 25. We knew that D was 35, so this is 17.5, 17.5. And now we know that this angle down here, this X, is 68.9. So with that, knowing that 68.9, I'd know this is 68.9 up here. And I think I want to go ahead and find fish. So let's see, can we do this in one step? Tempting. What changes here? I'm going to do it in 2 steps. So opposite of fish, I've got 17.5 squared equals 25 squared plus 25 squared minus 2 times 25 times 25 times the cosine of fish. Fish is cosine inverse of, it was 17.5 squared, have to subtract 25 squared and subtract 25 squared. Divide all of that by negative 2 times 25 times 25. And let's check that one out. I'm not even going to try to edit this one. I'm just going to clear that out. Resist the temptation. Second, cosine inverse with the extra parenthesis. 17.5 squared minus 25 squared minus 25 squared. All of that divided by negative 2 times 25 times 25. And we get 40.97 or 50.0 if we round. So 50.0 is this one. And if that's 50.0, that's 50.0. And I think we're in business now. Let's take a look. Would I know this angle? I'd know this angle. Do I know this one in here? Well, let's see. I've got this angle. 180, I'm just filling in things as I can. 180, I'm going for this one. Minus 50 minus 68.9. That angle 61.1 degrees. Let's see, that makes this angle 118.9 degrees. And what do I know in this triangle? I know this side 17.5, I know this side 17.5. Do I have enough information to find this angle? I do have enough information to find this angle. Because this triangle right here, I can law of sines this thing now. So I'm going to call this one y. And last part I have to find. Sine of y. A lot of organization. This is the toughest problem in this section. Sine of y on 17.5 equals, ooh, can I law of sine it? I can't law of sine that yet, can I? Take that back. I've got side, angle, side. I'm going to have to find this side, I believe. Unless we can see another way to do that. So I'm going to call this side, oh, this is A. We got to find it anyway. We got to find A anyway. You guys know that. All right, so here we go. I've got A squared equals 17.5 squared plus 25 squared minus 2 times 17.5 times 25 times cosine of 118.9 degrees. Holy cow, there's a lot going on this problem. And therefore A equals great big square root of 17.5 squared plus 25 squared minus 2 times 17.5 times 25 times the cosine of 118.9. And we get 36.8. A is 36.8. And now that we have that, I'm going to claim we have enough information left to find this angle. We've got plenty of, we can definitely law of sines this thing now. So now I can go sine of y on 17.5 equals sine of 118.9 degrees on A and S, or y equals 17.5 times sine of 118.9 degrees divided by A and S, and we have to take sine inverse of that. Second, sine inverse. 17.5 sine of 118.9, close that. Divide by A, which is my answer, second answer, and we get 24.6. If I've got 24.6, let's fill in the things that we need. I learned A. A was 36.8. There's A up above. A is 36.8. I just learned that theta, right down here, is 74.6. And this angle, I can either fill out this triangle here, the angle measures, and subtract from 180, find this, add it to, or I could just say, well, I know it's supplementary to, I know this angle is supplementary to theta, so this must be 95.4 degrees. Whew, that's a good place to stop right now. We got a short little part 2 video following up. Believe me, we just handled the problem that's the load. This one won't even be handled in the first day that we talk about law of cosines. So you've got that. You're certainly equipped to handle a lot of law of cosines. You can notice there's kind of a sporadic set of problems. When I'm going around picking them like that sporadically, it must be because I'm either trying to eliminate some busy work or there's some problems there that I really, really like. So as always, stay tuned and let me know what I can help you with.